Hi, welcome. In this video, we will solve problem missing number asked by companies like Adobe, Microsoft, Facebook and Amazon.
So let's check out this problem. So before solving it, I want you all to first pause the video, go through the problem statement, understand the input and output, and then watch the video. So let's get started. So given an array, so here we have given an array nums and containing n distinct numbers in the range of 0 to n. Return the only number in the range that is missing from the array, right? So basically that missing number. Okay, so first of all let me just quickly create this array. I will just copy it and I will simply just make it. I want a size of 3, right? So this will be good. Yes. Okay, so here let's see, there are three numbers 3 0 1. So I think this is pretty clear that this is a size of 3. Okay, so if I say n here, that is 3, right? But the range is 0 to n, so this is not that n we are looking for. Okay, so let me put something else so that it won't create confusion. So like let's suppose L as in length. So current length is 3, but remember that this is missing, right? One of the number is missing from this array. So what we need to do, we need to find that number. So 0 1 2 is missing, right? So the actual length is the, if I say n is that is 4. So the size of the array is 4, where the 4 numbers are 0 1 2 3. So the missing number here is 2, right? So this is the missing number. Similarly here, if I come here nums, now here in this array, just let me take 2. Yeah, so here in this I have elements like 0 1. Now what is missing, right? This is clear, 0 1. But this is sure that one of the number is missing from the array, right? So when there like all these things are sum up like 0 and 1, you are not getting any missing number, then the next number will be missing. So here again the missing number is 2. So the answer is 2. So basically always remember, here also the current length is 2, but the actual length, because the one number is missing, the actual length is 3, right? So if I talk about a range that is 0 to n, so that will be from 0 to 2, basically n minus 1, right? Because I am calculating all these things, right? So this is n, size of the length, and from 0 to 2, so 2 is missing, right? Here again 0 1 3, so 2 is missing. Okay, so I hope you got the problem statement clear, right? Basically it is a simple problem that an array is given, one number is missing, you just need to tell the missing number. So clear is that. So let's see how we can solve this problem. Let me just take this array and let's see how we can solve this problem. So let's take the same number. So I will go with 3 0 1, and just, so I want only 3 elements, so let's break this 3. So I want 3 0 1, and let me put the indexes, just giving all these names. So this is an array and the current length is 3, the actual length should be 4, and one of the element is missing, so the answer that is 2. So how we can solve this problem? Any guesses, anything you want to try, how you can solve this problem? Any idea? So let's to try it out to explain it in a more good way. So what I will do, let me use So let's take a good example to checking it. So what I will do, I will take this complete array, big size array. So let's put the number as 0, 1, 2, and let's suppose 3 is missing. So 4, 5, and 6, right? Let me put the indexes 0, 1, 2, 3, 4, 5. So this is my array, and so the current length of the array is 6, and the actual length is 7. So we have 7 elements, one of the element is missing, and the answer is 3. So let's check out how we can solve this problem. So what do you think? What could be an approach? So one of the approach that comes to mind, let me put that approach first, is basically you can sort the array. So here my array is already sorted, but suppose if it is not sorted, I will sort the array 2, 4, 5, 6, and let's assume like this is not sorted, so it will make a good sense. So let me 0, 1, 4, 5, 6, and 2, right? So this is not sorted. Okay, so now this is my sorted array. So this is my sorted array, and let me put the indexes. So 0, 1, 2, 3, 4, 5. Okay, so one thing is you can easily check it by the indexes. So basically you can iterate through this array, right? You can iterate through the array and you can check with the indexes. So basically if I say index, and you will check the element. So we'll check is the element is equals to index or not, right? So you will check if 0 is there, yes, both are same. If 1 and 1 same, 2 and 2 same, 3 and 3 is not same, right? Here should be 3. So what is the missing element? The missing element is, sorry, my bad. The missing element is 3. Right. Now let's take one more case, right? Let me put it here. And let's take one more case. Suppose if array is also complete, right? There can be cases. So case 1, this was. And let's discuss this case. So case 2 is like this. So you have an array and that is also sorted 1, 2, 3, 4, 5, right? So now what is the missing number? So the missing element is 6, right? So if I simply check here 0, 1, 2, 3, 4, 5, all things are present, where length is 6 again, and the current should be 7. So the missing element is 6 here. Now if you are using this approach where you are checking with the index and the element, right? So 0, 1, 2, 3, 4, 5, where you are checking index and the element, so you won't find anything, right? You will say that it is clear, right? So this is true, 0 and 1, 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, and that's done. So if complete array is sorted, or if complete array you won't be able to find a missing element, this is sure that in this array there is a missing element. So the last element will be your missing element. So what you can do, whatever the current size of the array is, that is your answer. So the current size is length of 6, though your answer is 6. That is your current length of the array. Okay, so this is one of the approach, right? And for this approach, what should be the time complexity? What do you think? So here you can see we are sorting the array basically. So the sorting part, first of all, see how many part is like it is divided. So sorting part will take big O of n log n. So here n, don't confuse with n, it is L log L, right? Because we are checking the current. So it will be L log L. Okay. And we are also iterating it, right? Remember this thing, element and index. So we will iterate with the element, right? So we are checking this one, element and index. So it will also take big O of L, that is the current length. So again, here and here, what is the maximum? That is L log L. So the time complexity will be big O of L log L. Okay. So this is the expensive approach. Like here in the sorting, you are getting big O of L log L, and then a simple iteration. Here you are getting L times. So the time complexity is big O of L log L. Right. So this is an expensive approach. Let's try to come up with different approach. So let me copy the same example. Okay, and let me paste it here. So now let's see what could be the next approach. So here, if we simply think in this direction that we can store these numbers, maybe we can reduce with time, but as there is a trade-off, so trade-off time complexity and space complexity. So if you want to decrease the time complexity, okay, you need to check with your space complexity, it will get increased, right? So it's a basic trade-off, right? And everything comes with a trade-off. So if you want to decrease the time complexity, right, decrease the time of the process, you need to compromise with your space. So now let's see how we can introduce any space and how we can solve this problem efficiently by using space. So what you can do, you can create an hash map or hash map that is in Java. You can create objects in JavaScript, dictionary in Python, that can be as in your space. So suppose this is my object, or you can say hash map. So if you remember that objects, dictionary, hash maps, all are these key value pairs. So what I can do, I can simply store this. So the basic approach of this problem is that we will store all the elements. So I will store 1 here, 1 suppose as true, okay. Then I will store 0, then I will store 2, 5, 4, 6, right? Same as like this. And what we can do, we know that this is the current length, that is 6, and we know the actual length, that is 7. So we can iterate through 7. So basically we can run a loop, we can run the iteration, that is I will start from 0 and it will go till I equals to 6, because the current n is 7. You know that one of the element is missing, right? So you will take this length in your this for loop, right? So you will take I equals to 6. I am saying I equals to 6. Don't confuse it, like here it is mentioning 7, why you are taking 7. This n is equals to 7 means there are 7 elements, right? But in an array, if you are using, you always start with 0. So it comes with like I equals to 6, right? If you can remember, we basically do like this: I equals to 0, I less than n, and then I plus plus. Okay. Or if you say less than equal to, then you need to do n minus 1. So the thing was this, okay, inside this for loop you can check, is your I present in the object or not? Is it present in the hash map or object? Let's see, this is an object. Okay, so if it is present in the object or not, right? So if I check with it, so 0, yes, it is present, and then after I plus plus, so it will be 1, is it present? Yes, it is present. Then after 1, 2, is it present? Yes, it is present. then after 2 it will be 3. Is it present? No, 3 is not present. So if 3 is not present, that means 3 is our answer. So the answer will be 3. So this is one of the approach that you can apply. So this was again case 1. Let's see what happen if we get an sorted array already. So I will simply copy this or copy this whole. And I will simply paste it here. So if in the second case, suppose we have elements like all things are present 0, 1, 2, 3, 4, 5. So even if this is the case, right, you can put all these elements in your dictionary, right? So suppose let me just use an object like here. Suppose this is my object, right? Let me mention it as 2, and I am mentioning 0, 1, 2, 3, 4, 5, that all these things are present in my object. Now again I will start a loop. I will start from there, and you can know I am going till n. What is the n here? Right, less than n, right? That means n minus 1, that is 6. So when I will go to 6, I will check, is it present in the object? No, it is not present. So then 6 will going to be my answer. Right. So this is the second approach. This is how by using objects, hash maps, dictionary, right? So I'm just telling about all these things in different languages. This is the same, basically a key value pair storage system. So if you are using this approach, you can decrease the time complexity. Now the time time will consume only here on your iteration. So the time complexity will be big O of n, or if I say big O of n, that is the actual element length, and that's it. And because you are taking this space, right, so the space complexity will be big O of L, you can say, right, because you will create any space of L elements only, but you will iterate till n elements. So remember. Okay. Now let's see one more case, one more approach, I will say. So let me copy this and let's see the next approach, what we can do. Are you coming with any of the observations, right? Because we have discovered 2 approaches so far. Okay, any other approach you can build by using spaces or by using any like time iterations, something. So let's see. One of the thing is what you can do, because we are dealing with these spaces, so you can create one more array, right? So suppose you are creating one more array, and this array you can take as the complete size of the n. So current length is 6, right? Actual length should be 7, because there should be 7 elements, right? And one of the element is missing here. So what I will do, I will simply add, just give me a second. So I add the element here, like add the space here. So you can see the size of the space is not 6, it is 7. So 0, 1, 2, 3, 4, 5, 6, it is going till 6, right? I am starting from 0, the size is 7. Okay. So now what you can do, you can initialize with suppose -1, right? This is your array. You can initialize with -1. And what you will do, you will iterate through an array, the array that is given. Right? Suppose, what should I call this array? Let's suppose ARR of 2, right? So you are iterating through this array, right? You are checking the element, and what you are doing, you are adding that element to the specific index. So suppose I got 1, I will go in my array 2, and I will check the 1 index and I will fill it there. So here I will add the 1. Now I will go to 0, I will check the next element is 0, right? So I will go to the 0th index and I will add 0 there. Then I will go to 2, I will go to the second index, right, and I will add the 2 there. Then I will check 5, I will go to 5th, right, I will go to 5th and add the element here. Then I'll check 4, I will go to 4th index and I will add 4 here, like this. Then I will go 6 and I will simply add 6 here, right. Now what I need to do, now it is clear, right? So just what I need to do, I need to iterate through here. I will start iterating in this way, right? And whenever I am getting -1, right, that means that element is missing, right? So here the answer will be -3. Sorry, -3 not, it is 3. So clear? What you have done, basically you have taken the elements and fill the element on that index in the array 2. See, filling won't take too much time, because here it will take constant time, because the array is already like in that is space in the order. In the memory it is already allotted, so you don't need to iterate through it. You just need to choose array 2 of 3 and place the element there, right? So here the iteration, let's see again what will be the time complexity of this approach. So what I am doing is, first of all, I am iterating through the element and I am adding the element here. So this will take big O of L times, right? Because you are iterating through this array and you are adding the element here. And then you will again iterate through this array 2 and you will check which element is -1, that is the missing element, right? So big O of L, big O of N, and the difference is only of -1. So if I go with the maximum, right, the maximum of 2, big O of L and big O of N, so the maximum will be big O of N. So the time complexity here will be big O of N. But remember, you have taken the space, so the space complexity here will be big O of N, because you have created a space of N here. So far we have discussed 3 approaches, and all these approaches are valid. If you want to test it, you can solve one of the question in the Leetcode. There is one question that is named as missing integer. You can solve it, okay. But still I want to optimize the time complexity, and I don't want to compromise with the space complexity. I don't want any type of space complexity. So for this we have also one of the approach. Let's discuss that. So here we have an array and we are discussing the approach number 4, right? So we have an array of some elements, one of the length is missing, one of the element is missing, sorry. So the current length is 6, the actual and it should be 7, and here the missing number is 3. So what you can do, you can take the sum of the array, right? You can simply find the sum of the array. So if you check what is the sum, so 10, 7 and 8. So what is the sum? That is 18, right? And you know that there should be n elements, right? You know this n, there should be n elements, right? So what you can do, you can simply calculate the sum, right? So because I am starting with 0, so n won't be 7, because this is a natural number, right? We are starting from 0. So I will take the n as n minus 1, right? And now what you can do, you can simply add the sum of natural numbers, right? So the sum of natural number is n into n plus 1 by 2, right? So here the sum will be 6 into 7 by 2, so the answer will be 21. 7 3 21. So here now you got a sum of natural numbers, you got a sum of natural numbers. So if I say you got a sum from 0 to 6 elements complete, and you got a sum of your current element, whatever the array is, right? So what do you need to do? What do you need to do? You just need to subtract it. 21 minus 18, that is 3, and that is your missing number. So this is the answer of this question. So far we have discussed now 4 approaches, and all these approaches are valid. What should be the time complexity? What do you think? So you are calculating the sum of the array, right? So you need to iterate through this complete array. So the time complexity will be big O of L, the current length, okay? And you are not taking any space. You are just adding one formula, that is sum of natural numbers, right? So time complexity is big O of L, and space complexity is big O of 1, that is constant. And that's it. So now in the next video we will check out how we can apply these 4 approaches and what will be the code of it. So check out the next video. You will get a complete code implementation of this problem.